Alright, dear students, today we're going to see how to balance an equation in basic solution. Right? This is called Redox reaction. So how can we balance this equation? It's really important to comprehend that when you talk about oxidation, there is a scale, right? And that scale is going to be related to the groups and the elements in the periodic table. So here, so the more we move toward the right side, we are going to oxidize, right? But the more we move toward the left, we're going to reduce. So we're going to have two types of substances, the oxidized substance and the reduced substance. Okay, so let us check this. Here, the substance that I have in the reactants are called permanganate ion. We have permanganate ion, and we're going to have iodine ion. And that will yield to the side of the products. Okay, that is manganese dioxide and iodide. So I'm going to write what is the oxidized substance and what is the reduced substance. Okay, so here, if you analyze, the iodine is going to have a negative charge, right? So by the way, as it is an ion, I will use its ionic charge to determine its oxidation number. In this case, it's minus. Remember that pure substances, oxidation number is 0, okay? So this is a pure substance because we only have one element participating in the molecule. Alright, so I'm going to write it. So I'm going to write that it's going to yield to but here we have to balance the number of mass that we have in both sides of the equations. So here we have 2 atoms of iodine, and here we have only one. So what I will do will be basically like I will write 2, right, to balance these, the number of atoms that I have in both sides. Now I will balance the charges. So in this case, I'm going to write 2. Right? And as I have one negative charge here, it's going to be 2, minus 1 times 2 minus 2 charges. So the question is, how many electrons do I need to add in the other side? So on the other side, I will write 2 electrons to balance my equation, because here you have 2 electrons, right? And have to write other 2 electrons on the other side. Okay, so now let's go with the next substance, which is the permanganate ion. So the permanganate ion is going to be something like permanganate neutral, right? Here it's really important to understand that I have to add hydrogen molecules with oxygen molecules. So I mean water, right? Why? Because I am in a basic solution. So water is the excellent solvent, but at the same time is the substance that will neutralize both substances. So in this case, what I will do is basically something. I will add the same number of oxygens that I have here, but in form of water, right? So I have 4 oxygens, so I have to write a water molecule, and as I have like one oxygen and 3 oxygens in total. I will write 2 oxygens, right? 2 water molecules. So I mean 1 times 2, 2 oxygens plus 2, 4 oxygens. So at the same time, I will have it here, right? So, but at the same time, I would have to write a hydrogens, because here I have like 2 hydrogens, right? So in total, I will have a 4 hydrogens. 2 times 2, 4 hydrogens in total. So I will have to add 4 hydrogen ions in this case, right? So at the end, I will have these expressions, guys. It's going to be 2 hydrogen molecules. Okay. Next, what you have to keep in mind is that the net charge for this permanganate ion is going to be -1. And if you want that I prove this, I will prove it here. Proof. So, the manganese oxidation number is +7, right? And the oxygen oxidation number is -2. So if you multiply 7 times the manganese atoms, and you sum up these to -2 times the oxygen atoms. Okay, so what's going to be the result? So I'm going to say 7 times 1 plus -2 times 4. And that's going to be 7 plus -8. Right? Okay, so I'm going to write 7 minus 8 equals -1. So the net charge is -1. Alright, so having known that, I would say that -1 times 4 hydrogen ions plus 4 hydrogen ions, is going to be 3 positive charges. So to compensate that, I'm going to say that permanganate ion is 4 hydrogen ions will need to be compensated by 3 electrons. Okay, so then I'll have to take both equations. I mean, this one and this other one, and I'll have to combine them in certain way to see what is in product. Okay, so as I have here 2 electrons, and here you have 3 electrons, so I have to compensate that, right? So I have to say I will multiply all of these times 3, and I will multiply all these times 2 to compensate all equations. And they will give me 6, by the way. So finally, I'm going to say 3 times 2, 6. Okay, in the reactant side. I continue with the other reactant side, right? Pass 2 manganese ions plus 8 hydrogen ions plus 6 electrons. In that to the other side, I go to the product side. So 3. Okay. 3 iodide I'm not gonna write these two electrons because I will leave it for the end, right? Because at the end, because of the convention, I can identify where are the electrons. So I continue with the other side of the equation, or the product side, the second product. So in this case, 2 manganese, continue, and that's 4 hydrogen ions, water molecules, sorry, and then override that's 6 electrons. Here I can cancel out these electrons with these other ones, and I can say that my final expression is going to be 6 plus 2 manganese. Give that 2. And this is my answer. And the result will give us 6 iodine ions plus 2 permanganate ions plus 8 hydrogen ions yielded. That will give us 3 iodine molecules plus 2 manganese dioxide molecules plus 4 water molecules. Alright, dear students, thank you so much for having watched this video. Hope that it has been useful for you. If you need any further questions or information, do not hesitate to contact me. See you guys.